how would I find that? I have this object that has these two forces acting upon it. And I know that it's not accelerating, it's moving at a constant velocity. You can even say that it's stationary if you want to be the same situation. What's the direction of the third force? Well, what quadrant will the third force be in? 1, 2, 3, or 4? It's going to be in the third quadrant. I know that third force has to be equal the opposite of these two forces. And so I don't really care what the direction is, so I can also ask you that. But what is the magnitude of that? How would you find the magnitude of that force? This one's actually quite a bit simpler than the one we worked in class. Let's stop here and how about at 150? This is my force. I want to know its magnitude. Stop at 150. Okay, good. C is right. My force is going to be equal to the sum of these two forces. And to find the sum of those two forces, I say the square root of 20 squared plus 25 squared, and that's equal to 32 newtons. It was C. Is that what y'all marked? C? Yeah. All right. So you still have some vector problems. I mean, vectors are still very important to this chapter. I think after chapter 4, though, we have vectors a little bit in chapter 5, or chapter 6, rather, but then we don't come back to them until next semester. All right, let's see what else we got up here. Are there any particular questions from tests that you guys have? No? All right. I think we've worked a lot of these. Why don't we, I'll go and look at some of the old test questions. What would y'all rather work on, projectile motion or 2D forces? I'm going to shift gears and look at projectile motion. Is that what you said? What did you say?
Forces.
Projectile motion? Okay, we'll do forces. We're going to come back to projectile motion now. Okay? Forces, y'all said, right? Forces? Okay. All right. I don't know if we've worked this problem. Number 23. This is on the fall 16 test. Have we worked this problem? I don't remember working it. It says a 2 kilogram mass is pulled up a smooth incline by a rope so that it accelerates at a rate of 1 meter per second squared. The rope is parallel to the surface of the incline, and if the incline is 30 degrees, what is the tension in the rope? So, first thing I want to do is just draw my forces. I draw my weight, Fw. I draw my normal force, Fn. I draw my force, F. That's the force, T, the tension that I want to know. And that's it. I know that it's accelerating at 1 meter per second squared, so I'll need to take that into consideration. Next step is I'll draw my coordinate system, and then I'll redraw those forces, but I'm going to go ahead and resolve them into their vector components. So I have Ft, Fn, Fw sine of 60, and then Fw cosine of 60. I think it's useful to always do this, even in an exam, especially if you're not real certain on what to do. Because if you're not real certain what to do, you just sort of start this process that you know how to do. You label the forces, you draw the coordinate system, and then things will begin to make more sense as you write it out on your paper. I think that, yeah, that's all the forces. I want to know this tension. I know what the force weight is. I know what the acceleration is. So this is going to be pretty much a one-step problem. The sum of the forces in the x direction is max. Oh, man.
The sum of the forces in the x direction are going to be Fw cosine 60 minus Ft equals to the mass, which is 2 kilograms, times AX. I know all this other stuff. Fw is 20. Cosine of 60 is 1/2. Ft, I don't know. This is 2. The acceleration is 1. And so I can solve this for Ft. So Ft equals 10 minus 2 is equal to 8 newtons. And so the answer there is going to be 8 newtons. That's a darn good test question, right? That sort of difficulty would be good. It would make it a bit more difficult, and I'd break it up into a couple problems if it had friction. Yeah? Oh, you're right. It would be -1. Let's see. So how would that affect our problem? Yeah, it would be 12. I got it wrong, didn't I? See? You got to be careful. The mistake that we made here is that this should be -1, and so this would be +2, and so this would be 12. Now if I stop and think about my answer, the tension being, it should be actually more than the 10 newtons, not less, because it's accelerating up. If it was accelerating down, it would be 8 newtons, not 12. Thank you, Rebecca. Almost missed it on the test. All right. Can I clear this? Any questions about this? Let's see if we can find another that's 2D. I think that's what students have the most difficulty with. Let's try this one. Which of these equations are correct? Fn minus Fw sine 30 equals 0. We all can see those, right? Can y'all see those even in the back, right? See? Which of those equations are correct? Well, just looking at them, it looks like the first one's correct. I can draw my forces. I have Fw. I have Fn. It does have kinetic friction, and since it's accelerating up, I have Fk here, and then I have this force F in this direction. And then I can think about, well, resolving my Fw. This is going to be Fw sine of 30, and this will be Fw cosine of 30. So that gets rid of that vector. And now I look at the various equations that I've come up with. Fn minus Fw sine 30, that's this force minus this force equals to 0. So that one's okay. F minus Fk minus Fw cosine 30 equals max. Is that one okay? The second one? It is okay. Everything looks okay there. Let's look at this one. F minus Fw cosine 60 plus Fk equals max. Is that one right? Now there are two problems with that. What are they? Cosine 60. There's that angle, right? And then plus the Fk. It should be minus Fk. Okay? So 1 and 2 are the correct answers. That would be A. You'll certainly have one of those too. We've done several of those. But you'll have one of those on the exam. I think we've done one of these. Do you want to do it again? Yeah? No? Okay. 4 kilogram mass is pulled across the floor using a rope. Coefficient of kinetic friction is 0.5, and the rope makes an angle of 30 degrees with the floor. If the tension of the rope is 50 newtons, what is the acceleration of the 4 kilogram mass? Take a few moments, write down all the forces, just try it on your own. In the process of this, you'll need to find the normal force. It's not going to be equal to the weight.
It's going to be something less than the weight. Then use that to find the kinetic friction. Then you can do the sum of the forces in the x direction is equal to max. I'll give you a moment, then I'll jump in. Alright, so I'm going to draw my forces. I have Fn, which I'm going to draw them off to the side here. I have Fn. I have F sine of 30, that's 50 sine of 30. Here I have 50 cosine of 30. I have Fw. And then I have Fk. My first order is to find the normal force, because in order to find the frictional force, I need to know the normal force. So I say the sum of the forces in the y direction equals 0. That's 50 sine of 30 plus Fn minus Fw equals 0. It equals 0 because it's not accelerating in the y direction. And so Fn then will equal to Fw, which is 40 newtons. That's 4 times 10 minus 50 sine of 30. Which is 15 newtons. So that's my normal force. And then, now that I know my normal force, I say Fk equals mu Fn. Mu is 0.5, so it's going to be equal to 7.5 newtons. That's 0.5 times 15. And then, the last step, sum of the forces in the x is max. That's 50 cosine 30 minus 7.5 equals to the mass, which is 4 times A. I get 9 meters per second. Is that what y'all got? Yeah. So solving that, I get A equals 9 meters per second squared. Another good example which I might see on the test. But again, this would be sort of the most difficult question that you would encounter. A 2D problem that includes friction would probably be the most difficult it would be the most difficult you'd encounter. But you know, if you know how to do them, they're all easy. Blair? Yeah, so friction is always opposite the direction of motion. She asked if friction is always opposite the force that you're pulling it on. Not necessarily, though, because we had that one problem earlier where we had an inclined plane and we had a block that was sitting on it, and we said that the force they were pulling up it with a rope, that force was up, and then the frictional force was also up. But in this case, the object was stationary, and it's like this force was acting to hold the block up, and this force was also acting to hold the block up. And so the best way to think about the frictional force is that it will always be opposite the direction of motion if it's moving, or opposite the direction that the object would tend to move. As if you took away those other forces, what direction would it move? In this case, it's moving in this direction, so the frictional force is this direction. That's a good one. All right? That's a good question. Any other questions about this? How are y'all feeling about the test already?
Yeah, it's a tough test. I want to tell you, like projectile motion and 2D forces, they're tough. But we've had a lot of prep for it. So I think that you've seen everything that's going to be on the test. It's really just a matter of practice right now.
Let's try to do one more problem before we leave, okay?
I know this gets arduous and a little boring, but it's useful for you just to see it over and over and over and over again. Let's look at another one. If there are no requests, let's look at Fall 14. We'll look at projectile motion primarily next time. Okay, let's look at number 19. It's a good, I don't want to say simple, but it's sort of a simple inclined plane because there's no funky forces acting on it and there's no friction either. I have this block, it's 10 kilograms, and then there's this force that's pulling on it. There's a tension. I have 100 newtons that's pulling down here. That 100 newtons, by the way, is transmitted to the block so that I get 100 newtons here. So don't be thrown off by the pulley. The pulley just redirects the force, and then the force is actually applied to the block. And now I want to know what is the acceleration of this block. Okay? So I go through the same process. I label all my forces. I got FW here. I have FN. Check, is there any friction? Nope, no friction, so I'm good to go. It would mention friction, or it would say that it's smooth. It doesn't even say anything here about friction. Okay, now I label my coordinate system. I'm going to go and resolve my vectors while I'm at it. I have Fn, 100, and then Fw, sine of 60, and Fw cosine of 60. And now I want to know the acceleration. I say the sum of the forces in the x direction is max. Since I'm not worried about friction, I don't even need to know the normal force. The sum of the forces then are going to be Fw cosine 60 minus 100 equals the mass, which is 10, times ax. Fw, by the way, is 100, so I'll just put that in. This is 50 minus 100 divided by 10 equals ax. And so we find that that's equal to negative 5 equals ax. Does that mean it's going up or down the inclined plane if it's negative in the negative x direction? It's going up, because remember, it's going in this direction, which is the same as this direction. We've rotated that coordinate system. Okay, we'll stop there, but listen, on Wednesday, we'll be doing projectile motion. So if you have problems, or I recommend that you print out the test so that you can have them to write on if you didn't today. Because we'll be looking at the last several years of tests for projectile motion. Have a great day, okay? Let me know if you have any issues.